will wait for a few more minutes. Till that time, we will start the introduction part. Myself, Pulkit Gupta. I'm DevOps team lead here in Talentica Software. I'm also AWS certified solution architect. Okay, so we will start the introduction.
So I'm Vivek. So I'm working in the Safeguard IoT services. I'm the product engineer there. So I just joined the Safeguard in last month. Previously I was working in the Informed Pacific.
Okay.
I mostly previously working on the Python language, and in Safeguard I was working with Python plus AWS.
Okay. Great. So since how many years you have been using AWS?
In old company, the server I know on the AWS, but my interaction with them is less.
Okay.
In Safeguard it's the daily basis.
Okay. So mainly you are on development side or?
Yes, development.
Okay. Okay. Great.
Hi, morning. I'm Anil. I'm working with Cognizant Delivery Solutions and I'm a Java developer. I'm learning Amazon services and previously I was with Google Cloud.
Okay.
So, AWS I'm just reading up.
Okay.
GCP.
Cool.
Hi, good morning. I'm working with Cognizant. I'm full stack developer. I'm trying to learn the DevOps here now. The basic level for this.
Okay. Okay. Great.
Hi, I'm Rahul. Currently working with 20 consulting as a program developer. Previously working with Formatic and I'm interested in Google Cloud Platform because Google language is Google language. That's why it's more suited to
Right. Right. So earlier you were permitted in this building only?
No.
That okay. I'm a student. Okay. Cool.
I'm sure.
We are MDocs. Okay.
Come
Yeah, I have seen you in many meetups. Right. On which platform you do work?
I am a company.
Okay.
Not just around the telecom companies are developing into public cloud.
Okay.
It is on-premise or privately managed open stack.
Okay.
I don't work on it, but it is coming.
Yeah, it is good to know that you do not work, still you attend regular meetups. So it is great. Yep.
I am Ruchira. I also work in Amber.
Okay.
And same thing, I mean, there is this journey to finally go to cloud. So,
Okay, so you work on development side? Okay.
And my name is Pradeep Dele. I'm working as a senior SAP basis consultant. I work globally. My project was on-prem, but now everybody knows it is switching to on-cloud, so I started to learn cloud.
Okay. Great.
Hello everyone, I'm Sharon Gupta. I'm working as a cloud architect with Telecom. I'm working mainly on AWS and Azure and a little bit of OpenStack. So now trying to learn Google.
Okay.
Hi, my name is Dilip Singh. I'm working in Talentica. I'm a full-stack developer. I know a little bit about AWS, so I just came to know, want to know that about Google Cloud Platform and comparison with AWS.
Okay, cool. Yes.
I'm from Bajaj. I work in Bajaj as a network associate.
Okay.
I just know basic. I just got a mail from him. I got opportunity, so I came for that.
Oh, great. So you work on cloud platform?
No, I don't.
Okay. Okay.
I'm working in Talentica Software as a system administrator. Just learning cloud.
Hi, my Rohit. I'm working as software developer since last 2 years. And
What? Sanjay? Okay, so myself, Pulkit Gupta. I am DevOps lead here in Talentica. I'm also AWS certified solution architect. So I'm with Talentica since last 5 years, and we are using lot of AWS services. Till now, we have explored with data solutions and compute storage. Most of the services we have been using with AWS. Now we recently started exploring Google Cloud. So as you all know, here in the work culture of Talentica, learn and share. So whatever we learn, we share with the people and in these kind of meetups. Okay, so let's start. So this is the agenda of today's meetup. So we will see what exactly is Google Cloud Platform. We will see what are the services and benefits. We will focus mostly on why we should use GCP. Okay, and what is the compute engine? We will see how to create a virtual machine using Google Compute Engine. We will see it. We will also have an overview of Google Cloud Shell, Google Command Line Interface tools, and in the last we will have demo discussions and question answer sessions. Okay, so let's start. Before starting, anyone knows about how many cloud providers are there worldwide, the major cloud providers, apart from AWS and GCP? Right. DigitalOcean. Heroku. Any other?
Alibaba Cloud is also there.
Yes, Alibaba Cloud recently started their platform. Cool. So these are the major cloud platform. I have not mentioned Heroku here. Still, VMware, Rackspace, DigitalOcean, IBM Cloud, Azure, and Zoyant, Samsung company, Paramount. So why AWS is in center? Because we all know AWS is the cloud leader, the major cloud provider worldwide. And most of the organization, we heavily used AWS services. And recently other cloud provider, right, like GCP, Azure, and IBM Cloud also growing. And although GCP has started 5 years later, AWS has started. The main important reason why AWS is cloud leader, because AWS has started its services in 2006. Right, the way earlier, the first ever cloud platform which started providing their services, and GCP started their services in 2011, 5 years later after AWS. And still, GCP has introduced their compute, the virtual machine platform, in 2013. So it's been only 5 years since GCP has started providing their services to public. So we will see what is GCP. Google Cloud Platform enables developer to build, deploy, and test all the applications on Google highly scalable and reliable infrastructure. It is a set of cloud-based services that allow us to create anything from simple website to the complex application. So this is the most simplest definition, the most simplest concept behind Google Cloud Platform. So how GCP is organized? Basically, GCP is organized into regions and zones. Regions, what exactly region is? Physical, geographical locations. And zones region is a collection of zones, and zone is a collection of data centers. Okay, zones are isolated deployment areas in region. So our resources, our instances, our databases can be regional, zonal, or in some cases multi-regional. And this is the global network of Google Cloud, which has the point of presence in more than 100 locations. All these blue lines, you are seeing the fiber optic cable, undersea cables, which are interconnecting all the point of presence. And just for your information, this is the actual picture of Google data center. From the past 15 years, Google has been building out the fastest, the most powerful, the highest quality cloud infrastructure on the planet. So I think this is the more important reason we should know why we should choose Google Cloud Platform, because we know all the services on Google has been providing to us, the YouTube, Gmail, Google Map, all these services. Google has hosted all these services on their cloud itself. Although Google started providing their services to public later on. Why Google Cloud Platform? So I have got this from Wired. Google's ability to build, organize, and operate a huge network of servers and fiber optic cables with an efficiency and speed that rocks physics on heels. This is what makes Google Google. Its physical network, thousands of fiber miles, and those many thousands of servers aggregate add up to the mother of all the cloud. This is again an original picture of data center. So when we build our infrastructure on Google Cloud Platform, we have that much of confidence that we are building on Google's fast, scalable, and highly reliable infrastructure. So we don't have to worry about the hardware, the security, and other things which we should care while building our platform. Okay. And the most important parameter, if we compare it with AWS, because we know when we are running our business, the important thing which matters is the cost, which is the most important factor for our customers. So I have done the comparison with a few of the common platforms like EC2 instances. So I came to know that the pricing of GCP is 15 to 41% is less expensive than AWS. So you can see the comparison here. This is the M4 large instance, and which has the custom 2-core and 8 GB RAM. It prices $87 per month in AWS, and where it prices $54 per month in GCP. So you can see clearly it is 37% cheaper than AWS. And again, the another instance 15%, 40%. So this is the comparison of only EC2. There are a lot of services which are cheaper than AWS, so we can save a lot of cost in our infrastructure. Again, the next important parameter which we can test, the guys which have been working on AWS, they can understand better. The VM fast boot times, if we launch a virtual machine in AWS, it generally takes around 3 to 5 minutes, maximum 5-minute times. And GCP, it is in seconds. In 10 to 15 seconds, you click, launch your instance, and it gets ready in 10 to 15 seconds. So this is the most important feature in our large infrastructure where we need to deploy hundreds and thousands of servers. So within seconds, it gets deployed. Where in AWS, it takes time, in minutes. Another thing is higher write speed. Read-write speed, you can see here the ephemeral writes, the persistent disk writes. So we know the higher the read-write speed, what is the throughput. Okay, so herein you can see the GCP read-write is on ephemeral stage is anytime faster than 150 megabytes per second. Here also in persistent disk, it is better than AWS, and on read speed only. Read speed also is better than AWS. So higher writes and VM fast boot are the another parameter which are better than AWS. The another parameter are network. On the starting slides, I have shown you how powerful, how large Google's network is. We all know Google has the world's largest cloud network, and that is why it provides a way higher bandwidth, and which is better than and faster. It provides faster up and down links. So it is 300 MB per second, whereas AWS provides only near about 50 MB per second. And the latency is also very low in this GCP. Lower latency, we know lower latency is better and means shorter wait time. So latency is around less than 25 seconds, milliseconds in GCP, and in EC2 we can see it is somewhere around 1 minute. Maximum latency it is there. So whenever we just if we ping, we download any data from one of the data centers on AWS, so it takes time, whereas in GCP it gets downloaded within milliseconds. So we will see some other facts why we should opt Google Cloud Platform. Although AWS is a market leader, although AWS has been providing its services since last about 12 years, although it has a lot of services, but why we should choose Google Cloud Platform? We know all the startups are migrating their platform to clouds. Okay, so the main reason we build the infrastructure that allow Google to return. We build our application on the same infrastructure that allows Google to return billions of search results in milliseconds. We know it's Google search. We search and it gives us millions of results in milliseconds. The platform which serves 6 billion hours of YouTube video per month and provide storage for 425 million Gmail users per day. So we can see, we can imagine how fast, how reliable is Google network. Mix and match services it provides, although Google started their services 5 years later when AWS started, but still it is in growing phase, it is in developing phase, and Google provided the lot of services till now. So it may be virtual machines, managed platform, block storage, NoSQL data store, MySQL database, anything, and big data. It is amazing. We know all these things are managed. Google is managing very smartly the big data things, the machine learning, artificial intelligence, all these things. There is no comparison of GCP. Although AWS has all these features, but once you start these services, once you start exploring these services, you will see the difference. The next thing, performance. Google's compute infrastructure gives you consistent performance, consistent CPU, memory, and disk uses. It is okay. You can. Okay, so this is the most important factor when we consider, when we compare the cloud provider. The next thing, the support, the worldwide support from the free community, the Google forums, Google groups, and 24/7 phone support if we get the premium account. So let's go to the next level, cloud computing service level. Any one of you knows about these things? IaaS, PaaS, SaaS? Yes, please.
Infrastructure as service, platform as service, software as service.
Yeah, so what exactly it mean?
The cloud providers provide you the complete infrastructure which will be required for your organization to maintain the servers. This is the IaaS.
Correct.
And like the deal with the cloud providers for getting infrastructure. same way like our platform as a services, you can choose the platform to work on, work for your organization. For example, like host.com.
Right.
Yeah, like SaaS, it is like a software as a platform. Same way like that, Google or any cloud service provider, they provide the service for the organization or users with the available softwares which they are requesting.
Correct. Excellent. Absolutely correct. So, although these are the major building blocks of cloud computing service level, there are some other like function as a service, container as a service, time as a service. But these are the major component, major service level of cloud computing. So, infrastructure as a service, as you told, we get the complete infrastructure. For example, the AWS, where we don't have to worry about the hardware, anything. We get in the simple click, we can have our virtual machine ready. We just need to choose the hardware like the compute, memory, processing power, memory, disk storage, and your machine is ready. So complete infrastructure we get. So in infrastructure as a service, we have all the cloud provider, EC2, Rackspace, Google Compute. What is the platform as a service? In platform as a service, we get complete platform and we don't have to worry about selecting the operating system behind it, right? So for example, Google App Engine, AWS, Amazon, Elastic Beanstalk, where we can easily deploy. We get the platform, we can easily deploy our application on that platform. For example, we get this the complete stack, the LAMP stack or anything we can deploy within seconds without worrying about the infrastructure. Software as a service, the top level. So we get complete software as a service. For example, Gmail, Yahoo Mail, and other things. So we get this. So these are the building blocks, the service level of cloud computing. So now we start the Google Cloud Platform Services. So basically, Google GCP services are mainly categorized as compute, storage, big data, and machine learning. So in compute, we have these all like virtual machines. We can quickly launch virtual machines. We can have load balancing. We can have auto scalings, and all required to build a machine for auto scaling or to add a capacity. The next thing is storage. So where we can store our data, the big data and machine learning. These are the services provided by right? So which are the most important services? Under compute section, you can see this compute engine, container engine, app engine, and cloud functions. Okay. So today we will see one of the most important service, compute engine. And the storage side, we have this big table, cloud storage, cloud SQL, cloud spanner, cloud data store. The big data size, BigQuery, PubSub, Dataflow, Dataproc, and Data Lab. Recently, Google has launched a lot of 3 to 4 more services. And machine learning, the amazing stuff, amazing job which Google has been doing since many years. The Vision API, machine learning, speech API, translate API, and natural language API. So, anyone knows about Amazon Echo? What it is?
It is a book, which is just like a book. You can interact with Echo and you will get information on your phone.
Right.
Voice assistant.
Right. So recently they started a lot of marketing. Yesterday only I saw a full 2-page article, the advertisement in Times of India. So the thing is the Echo, what they have done, it is a machine, a small machine, and you can interact with that machine. It will answer most of your queries. Like you can say, echo what is the temperature today, what is the latest news, and it will start playing. Although it is in a machine, but Google has been providing since long time, right? So we all must have seen it is in Google web browser. We can simply give voice command and it will return the search. So this is the same thing. Amazon Web Services has launched in hardware, although later on Google has launched the same thing in Google Alexa. Not Alexa.
Google Assistant.
Google Assistant, right.
That is a hardware.
Yes, yes, yes. Google Assistant. So, the compute engine, virtual machines which are hosted on Google Cloud infrastructure, so it comes under an infrastructure as a service. App engine, we can deploy our code directly to a fully managed platform. So it comes under platform as a service. It is same like a Elastic Beanstalk. And the next is container engine, where we run Docker container cluster on Google Cloud platform. So it is a container as a service. It is the same service which AWS provides. It's like ECS, Elastic Container Service. The next major services under storage, big tables, cloud storage, cloud SQL, and cloud data store. So cloud SQL is a full SQL support for online transactional OLTP system. And cloud data store, it stores highly structured object and query with SQL-like statement.
Is that data warehouse, cloud data store?
No, data warehouse is BigQuery. So it does not come under storage, it comes in big data tools. This BigQuery. Cloud storage store immutable window of object which are greater than 10 MB, for example, images, videos, and big. It is like AWS S3.
What is the mapping to S3 here?
Cloud storage. Yes. And the big table, it is high performance, extremely scalable, no SQL database. It is the same as AWS provide Amazon DynamoDB. Alright, so these are the big data services. The BigQuery, it is analytics data warehouse. We can stream data at 1 lakh rows per second. The data flow, stream and batch processing of data, unified prawn model it is. The PubSub, scalable and reliable enterprise messaging middleware. The Dataproc, managed Hadoop, Spark, Pig, Hive at very, very affordable price. So it is the same like AWS provides EMR, Elastic MapReduce. The machine learning, the wonderful, amazing features of AWS, machine learning, artificial intelligence. Vision API, machine learning, speech API, translate API. I have only covered the important services. It has lot of services under machine learning. So Vision API, we can recognize objects and images. Machine learning, we can build our own machine learning models. Speech API, it recognizes speech and convert it the text. And the translate API, this feature since last so many years in the Google Translate, in the form of Google Translate, where this is the first things like Google had provided in the lot of language we can convert in any other languages, right? So anyone knows about what exactly is machine learning? Okay, so machine learning is basically it is an idea in which we can let the machines know without being programmed to know to do the jobs. For example, a basic example I should give. Nowadays, you must have seen in the Gmail in mobile Gmail apps, and any of your friend, your colleague, if he sends, I have done this work and this and this. So automatically, when you open that mail, you see some tabs in that under that mail. Thanks for update and any other things. So this is machine learning. which reads your message, which without programming, it automatically gives you a suggestion. So you can simply tap on that, thanks for the update, or thanks for the notifications, and so you can simply click on that tab and it will automatically reply. This is machine learning. The important factor, which I already shown you, the price. It is way cheaper than AWS. So yes, please. So per second billing is there. This is another wonderful features. Not per minute, not per hour, per second billing. So pay what we use. If we are using our instance for 10 seconds, so we need to pay for that much time. Sustained use discount. This is another big thing which makes a difference with AWS, sustained use discount. If we are using any of the resources for more than 25% of the month, more than a week, more than 7 days in a month, then Google automatically provide us the discounted price. So it may be till 25%. If we are running a virtual machines more than 7 days a month, so it automatically discounted price will be applicable in our billing dashboard. The compute engine custom machine type. This is another wonderful features. So we all know AWS provides us a lot of choices of instance type, the small instance, medium instance, large instance, higher memory, higher CPU. But what if our requirement doesn't fit anywhere, right? I want 4 CPU, I want 10 CPU with 120 GB RAMs, and there is no option no cloud provide this. But we have this facility in AWS. We can choose our virtual CPU and memory and hard disk, and we can create our custom machine. GCP. AWS does not provide this. I am telling about this is the feature of GCP, the custom machine type. Preemptible instances for cost saving. So it is like spot instances which provided by AWS, but preemptible means these instances can be terminated or will be terminated once in a 24 hours, but it is 80% cheaper of actual price, right? So these are the 4 pricing options in GCP, which due to these AWS GCP is way cheaper than GCP is cheaper than 41% cheaper than AWS. So the next thing is, how do we interact with Google Cloud Platform?
Okay.
So there are 4 ways in which we can interact with Google Cloud Platforms. First is Cloud Console. It is a web-based interface where we can access all the resources. We can create our custom machines. The next is the Cloud SDK, Cloud Shell. It is a command line interface. We can execute all the commands and we can launch our machines with the help of command shell. We can have the access with the API, and Google also provide the Cloud Console mobile apps. With the help of that, we can access the resources of Google. Projects. All Google Cloud Platform services are associated with a project that is basically used to track resources and quota users. It is We can track our billing based on projects. So project basically it is a way of organizing our resources, right? So we can have multiple projects, for example, development, for staging, and production. We can have 3 projects. So in development projects, so we can categorize all the resources which are using in production. Okay. So all the important things now, all the resources comes under projects. So and Google Cloud Platform Console, it is a centralized console for all the project data. So we have all these things under Cloud Platform Console. Cloud SDK. SDK includes CLI tools for cloud platforms, G-Cloud, cloud storage tools, BigQueries, all the Docker images are available. Anything, it is like if you are aware of AWS CLI, so Google provides the Google SDK, which comes with the CLI tools. In the next slides, you will see lot of amazing features which are better than AWS. Identity and access management. If we are using resources in console, then we need to manage who can access what resource, right? So we can do all these things. We can create users, we can give permission to those users with the help of identity and access management. Now comes the Google Compute Engine. So among all the services, we will focus on this thing, Google Compute Engine. High performance virtual machines, we can simply click, as I explained in my previous slides, we can launch virtual machines in seconds, right? So it is very high performance, powered by Google's global network. Per second blink is there. It is very fast and easy provisioning, right? It is very secure. If we build our applications on Google platform, then we don't have to worry about security, and it is a click to deploy. So how we can launch resources? So images, Google provides public and custom images. Public images, for example, if we have to launch CentOS machines, Red Hat machines, so Google provides all these flavors in which we can launch. And custom images, we can create our own custom images. From one of the public image, we can download the software as per our requirement. For example, MySQL, Apache, LAMP stack, we can launch. We can take an image of that instance and we can create a custom image as per our requirement. Project and instances, each instance belongs to a project, and project can have any number of instances. It is limited to like 5 VPC per project. It can be changed. By default, it is 5 VPC. Yeah, VPC is virtual private network, which any like cloud providers provide you the complete secure private cloud in which you can define the subnetwork range. You can have all these things. You can see infrastructure as a network. You can define the subnet. You can define the route table. It is a very secure private network. No one can access without your access levels. Right? Route table is there. Internet gateway is there. And lot of other things which makes your network more secure.
5 different domains.
Sorry?
5 different domains.
Not domain, 5 different network, right? So if one of my project, I need to make it very secure. By default, we can have a security group under which we launch and we can open the TCP and UDP port as per our requirement. But what in VPC, and if we launch our resources in virtual private cloud, so we get complete freedom. We can specify subnet range. We can have the IP, the internal IP, the external IP as per our choice, and we can define where is the what should be the in and out data flow, what resources can send data to our VPC, and the out data and in data flow we can manage, we can control it. Okay. The machine types, we define machine types and the custom machine types. So this is again a good features of GCP. So we can have the custom machine types. So as I told, if predefined machine types does not fit as per our requirement, then we can have our custom machine types. For example, n number of CPU with n number of memory and disk. Machine types are standard, high memory, high CPU, shared core. Okay, we can also attach GPU, graphical processing unit dies, to most machine types, which gives you a wonderful graphics. Okay, so high memory types, what exactly it is? It provides more memory per CPU. It generally gives 6.5 GB RAM per core. So where we require more memory as compared to more processing, so we can launch high memory machines. High CPU, where our resources required lot of CPU, so we can launch it. For example, our big data jobs where the lot of processing power is required, so we can launch in high CPU machine. And if any of our resources, for example, mem cache, we have to store our data, so we can use this high memory machines. Custom machines. So as I told, if none of our predefined machines types fit our workload, we can have anytime we can have a custom machines. So we can define how many number of cores and RAM we require, and we can create our infrastructure accordingly. So this is a comparison of machines with AWS, where AWS provide this T2 and T2.micro instance shared core. So Google provides F1.micro and G1 small instances. The standard machines, AWS provides M series, M3 medium, M3, M4. Here Google provides N1 standard, right? Standard, it is a balance CPU and memory. High memory, AWS provides R3 series, R3, and Google provides this N1 high mem 2. So it means it is a 2 GB RAM, N1 high mem 32 GB RAM is there. High CPU, the C series, AWS provide this for the computational purpose, and here GCP provides this high CPU. It is 2 core and 32 core, right? Billing models. The important things: all machine types are charged for a minimum 1 minute, and after 1 minute, it is charged per second basis. Anytime we can stop. If we are not using any of our instance, we can stop it, not terminate, we can stop it, and we can again restart it. The preemptible instances. Another good thing, preemptible means they might be terminated at any time when Google Compute Engine needs the resources, at any time. So don't get confused with the spot instances which are provided by AWS, because preemptible instances are cheaper than 80% of the actual price of on-demand instances. Okay, so they can be terminated at any time, but if we need a lot of resources for our testing, for the staging environment, so anytime we can have it.
So it's not based on costing, it can be terminated by Google anytime they want. Just like that.
Costing, it is there.
So in a spot instance, like we do bidding.
Correct. So bidding is not there, but costing is there. For example, if per month if it is an instance price is $1 per hour, then you can get in 20 cents. This is preemptible instances, but no bidding is bidding is not there. But Google can terminate those instances without with a prior notice of 30 seconds. That your instance is going to terminate it in 30 seconds. So in those 30 seconds, we can have our automatic backup mechanism in which we can launch another set of instances.
So it is not automatic. Snapshot is not automatic.
Snapshot is not automatic. We have to take. Why? With the help of our automatic scripts. We have the 30 seconds time window. In that time window, right, we can launch next set of instances. So will be definitely terminated after running for 24 hours. So this is the important parameter to understand. So this is basically for completely for the testing environment, not a production environment. So we can smartly use for production environment, although this is not recommended. Like we can launch thousands of machines for very heavy infrastructure. Yes, thousands of machines we can use, and we can very smartly we can write down the automatic scripts, and during that notification period of 30 seconds, our infrastructure will be the next infrastructure will be ready before termination. So it will not impact that much to our production environment. Okay. Some restriction is there. We cannot live migrate, and we cannot auto restart on maintenance. So it is acceptable. Next option is storage option. Anyone is aware of this SSD? Okay. So correct. So this is the much better than normal hard disk, and 20x faster read write is there in SSD, solid state drive. So each instance comes with a small root persistent disk. It is like EBS, a small root persistent disk, and additional storage options. We can add additional persistent disk, which are two types of persistent disk: standard and SSD. And the next is local SSD and cloud storage. Local SSD, it is same like AWS provide the ephemeral storage. Although it is very fast, but it gets terminated, it gets deleted once your instance gets. Okay. And the next thing is cloud storage. So these are the storage options. This is like AWS S3.
Is cloud storage like EFS or
S3? S3. Okay. Persistent disk, two types: standard and SSD. Standard persistent and SSD persistent. So regularly hard disks, although they are cheaper for sequential access, but for random access, for example, for databases where we need very faster I/O, so we should opt the SSD persistent. Okay. Local SSD, it is physically attached to the server that hosts your virtual machine instances. As I told, the data you store on a local SSD persists only until you stop or delete the instance. Although it provides very high I/O pace and very low latency. Cloud storage buckets. So we should use when latency and throughput are not a priority. When we want to store very huge amount of data, and when we want to access data worldwide or from multiple instances. For example, data, the analysis of big data we can store on this cloud storage.
This thing zones, is it like AZ in AWS or what zones?
By default, cloud storage provides multi-regional storage on this. So multiple, when you must share this, you are asking, when you must share data easily between multiple instances or zones. So cross-zone replication, cross-region replication, you must have heard. So we can access easily from multiple zones, from one data center, from another data center, so we can access that data, right?
Google has data center in India?
No, not exactly data center, but his location is there where they cache the data, right? So they have edge locations, and they have planned to have the data center, the region Mumbai region in Asia, Mumbai. So in 2018 they are planning to launch. Right, so cloud storage, so we can create buckets. Bucket is nothing but a simple which I have told that multi-regional. By default, it provide multi-regional. We are in AWS. We have to enable this feature. By default, AWS does not provide. We have to enable this cross-region replication on the S3 buckets. Whereas in Google, it is provided by default. And nearline and cold line storage are the feature of this storage class. So we will see multi-regional, it is frequent access from anywhere in the world, right? If we store our data in multiple regions, for example, in US region, in Europe region, so we can our data is replicated in multiple regions, so we can access it frequently. And nearline and cold line storage, so it is like infrequent and glacial. Fine. So it is, if we want to access our data less frequently, once in a month, so we can store it in nearline storage. If we want if our customer are accessing our data very rarely, so we can store our data in cold line storage. So this is again a very cheaper options under cloud storage. So again, we can have 80% discount in this storage. SSD or HDD disk, right? So use SSD unless we are not bothered about cost. If cost is not an option, then always we should use SSD, which are 20 times faster than HDD. Okay, so we get more predictable throughput. Don't even think about hard disk unless storing more than 10 TB data. So HDD, where exactly we should use HDD. So if we want to store raw data, and if we want to store any of the data which we are not accessing frequently, so we can, and which is very bulk amount of data, right? So we can store in HDD. If more random access there, like in databases, where frequent in out are there, so we should always choose SSD. So this is the comparison. Standard persistent disk SSD. So it is same as EBS, Amazon EBS. SSD, local SSD. This is the ephemeral storage, and this is like S3 buckets. Okay. So storage type, price, and maximum space. So we can see cloud storage is way cheaper than all these options. 0.007 standard, and these are the costliest. Although SSD is costly, but they are the very fast and reliable. Persistent disk versus Amazon EBS. Here you can see the difference. Volume types, AWS provide these many types, and GCP provide these. Okay, so volume, we can attach only one volume. Can we attach to only one instance at a time? So we can attach EBS at a time to only one instance, but GCP provides read-only volumes which can be attached to multiple instances. So you can see this is again a good features. We can attach read-only volume with multiple instances. So while creating our volumes, we can give an option. It should be a read-only or it should be a read-write volume. If we want to attach with the multiple instance, we should select read-only option. And here you can see we can attach the limit. The limit is up to 128 disk per instance, and this is 40. 16 TB and 64 TB. Here you can also see the difference. Maximum volume size is 64 TB per disk, right? So if our infrastructure is very huge, then this is a good option.
Per instance, is 40 what? TB or
40 volumes, not TB, numbers. 40 disks we can attach per instance, right?
this?
40 disk means 40 volumes, 40 hard disk we can attach, right? Additional disk. For example, if we want to use 10 petabytes of storage in our instance, then we need to attach these many disks, right? The compute features. Virtual machines, we call it instances in EC2 and instances in Compute Engine GCP. The machine AMI here in EC2 we call it AMI, Amazon Machine Image, and in GCP it is called image. Temporary virtual machines, as I explained, spot instance and preemptible VMs. Although there are difference behind the concept of spot and preemptible instance. And the security group, it is called in Compute Engine firewall rules in GCP. Auto scaling, it is called Compute Engine auto scaler. Ephemeral disk, as I explained, it is a local SSD in Compute Engine, right? Storage options and big data. So we can use block storage for compute VM for as per our requirement. So we can use persistent disk or SSD. If we want to use very like object storage, any kind of object storage, videos, images, PDF files. Hello.
Pulkit,
Yes.
sorry for disturbing you. I cannot see your screen. Can you please share screen?
Just now or sorry. Is it okay?
Wait. Yeah, okay. Thank you.
Thank you. Okay, so we can use this cloud storage for object-based storage. OLTP, we can use Cloud SQL or Cloud Spanner, online transactional processing. If we want to use, if we want to store our NoSQL documents like XHTML, XML, so we should use data store, the service provided by GCP. If we want to store NoSQL key values, so we should use big tables. And getting data into cloud storage, so we should use transfer service. If we want to transfer our data from S3 bucket to GCP cloud storage, so Google has provided a simplest transfer service where we should give the keys, access key and secret key of AWS, and in within seconds all the data will get replicated to your Google storage buckets. So as per our need, we should use all these things. Storage for compute, block storage, we should use this persistent disk. If we want to store media, object file, cloud storage, SQL interface, we should use this BigQuery. This is again a very, very good platform for data warehousing, right? So it is way faster than AWS Redshift. In our infrastructure, we have more than 350 TB, not 350, we have more than 950 TB of database, and earlier we were used to store in AWS this RDS, but we recently migrated our data to from Redshift to BigQuery. We migrated it. So very lower latency and fast processing we are getting there. Redshift is a data warehouse service provided by AWS. So because most of us are familiar with AWS, so I am comparing all these services with AWS, and I am explaining how these services are better than AWS, right? So document database, data store, these are the services provided by GCP. Fast scanning if you want, we should use big tables, and OLTP, online transactional processing, we can use Cloud SQL and Cloud Spanner. Cloud Spanner is a cluster of databases, right? Cloud SQL is a simple relational databases services. Cloud, it is kind of Amazon RDS. So here it is called Cloud SQL, and the cluster of databases are called Cloud Spanner, where we can auto scale or down scale our cluster based on the requirement. And data warehouse, we should use this BigQuery.
Cloud SQL, so is it MySQL or like that?
Right. It is as of now, Google only provides MySQL and PostgreSQL for storing our data. AWS provide lot of other databases as well. Right. So in AWS,
There is no other database.
correct. Only two. MySQL and PostgreSQL. So recently they started adding PostgreSQL in 2017 only. Earlier, because the thing is that they are in developing phase, they are gradually starting exploring their services, and but once that service is available to public, it is very affordable, very cheaper price, and at very fast performance is there as compared to other cloud provider. So these are the useful links. Google
Free for 1 year?
Yes. So another important feature.
300 credits.
$300, around 40,000 rupees discount, not discount, the free credit. So here also, it is better than AWS. AWS in free trial, we get 750 hours per month, right? Data for 1 year. We don't get the free credit. Right, so we can launch free services are there. For example, we can launch only T2.micro instance, which comes under free tier. They are free tier. And here in Google provides $300 free credit. You can launch anything. You can test anything if you want, like TPU, Tensor Processing Unit. It is very faster processing unit, which cost is around $7 per hour. Around $4,000 to $5,000 per month. The most expensive thing you can launch in this Google Compute free trial. On the product feature, you can get the tutorial getting started. The best way to start Google Cloud Platform is to create a free trial account and start exploring the things. You can go through the quick labs. You can go through these. There are a lot of tutorial. It is a worldwide free community. Google groups are there. Google forums are there. Lot of wonderful documents, which is self-explanatory, right? And this is the status of Google Cloud dashboard, where you can get the status of all the services.
How many certifications?
Yes, we have Google Certified Solution Architect. We have. No, we just started exploring these services, right? So I have planned to do that, right?
I think you're ready.
I don't know, but I will appear for that. Right. So
are you aware that static websites can be posted there? It's like that S3 can post a static website.
Yes,
So this cloud storage.
Cloud storage can anytime host static websites. For dynamic website, you should use the EC2 instances, right? Dynamic website where
no, I'm still asking this is static.
yeah, static website anytime with in easy steps you can get it hosted on cloud storage. Right? There is nothing, the HTML files you need to put on this cloud storage, and it will provide a URL cloud.api.com. So that link will be there and you can access. So now we will see the demonstration how to create virtual machines using Google Compute Engine. Any questions till now? Although we will have a detailed question answer session in the last. If
previously everything used to be about AWS and I know that Identica was then the motivation customers on AWS asking you to switch to Google.
the important thing for customer is price, costing. How can they reduce their cost with improvement in performance of their resources, right? So not our customer, we are telling our customer to switch from AWS to Google, right? Because most of customer don't know these things, know in the sense like where to migrate, where this. So here we do research and development all these in cloud technologies because we know Google is in developing phase. Although Google does not have a lot of services than AWS, but we should actually started migrating our platform to Google. For example, recently we migrated Redshift to BigQuery, and we did the analysis, complete analysis, and we came to know it is very cheaper and very fast processing is there in the BigQuery, right? So nowadays, not most of the people are aware what GCP is, what are its services, and how cheaper and faster it is. So it is our duty to tell our client, to tell our customer that we should provide the complete analysis and we should give case study to them. Right. Yes. Not existing, not complete infrastructure, only the big data solution, Redshift to BigQuery. No efforts are needed, just we have to take care for the live migrations, right? All the data, first of all, we should, because all these cloud platform supports the data transfer from one cloud provider to another cloud provider. So for example, we need to, if we want to migrate our databases, so first of all, we have to take backup of all the databases to our Google Cloud platform, and then we can simply cut down the inserts from AWS to, we can start those inserts to Google Cloud.
Essentially, it is something which the Google Cloud platform provides documentation how to migrate.
Right.
So
because
correct.
Correct. Because Google Cloud platform is is attracting their customer to switch to their platform.
So you migrate data over the internet?
Yes. Because it is a live project, so.
Would have taken a lot of time. Or the data
Correct.
was not there much.
No. First of all, we took its complete backup of our data. Not S3. In this cloud Redshift storage data, we took the database dump and we import that dump to this Google BigQuery databases.
The customer was live, like insert of the
No. We scheduled the downtime of around X window. So in that downtime, we did this complete migration.
The customer asked for live migration. So for that,
that depends on the size of your data, right? And a lot of other features. Anytime you can do live migration, but some little bit downtime should be will be there.
Backups are allowed.
Right. Incremental backup and
move it, and then you keep on doing incremental.
correct. Redshift and RDS provides us the incremental backup, automated snapshots we can convert, and we can take not weekend, it automatically takes.
Care of all these things, incremental backups later.
Correct.
What is the backend for the Redshift eventually stores everything on, I mean, it is built on top of Postgres, so there's a bunch of Postgres written on top of it.
Right.
What is the equivalent for BigQuery?
Equivalent of BigQuery is actually it is Postgres SQLs only, but the thing is that in backend we don't get the hardware access, the database access, the backend, like on which platform they are managing the databases, right? Because these are the managed services. These are the managed services, and although we knows the which database version you are using, but you don't get the physical access to those databases.
So one of the slides you mentioned on query mode files, so that's why I was curious why you mentioned that specific query mode files. So you import it and then the interface that they provide is only SQL, right? So I thought that if they at least
No. It is not like that. Okay, so this is the dashboard. Cloud.google.com. Right. Starting, I will show you. This is the free tier. 12-month, 300 free credit to get started with any of the GCP product. And another important things, few of the services are totally free. For example, X amount of data storage, for example 5 GB data storage and single core and 1 GB RAM. You can get it running absolutely free without any cost. So due to these are the amazing features, I started loving GCP, although I am a solution architect of AWS. So you can see these are the always free product. 5 GB data storage, instance hours per day, and NoSQL database 1 GB. So these,
always free.
yes. So these many services you can get, like n number of services. And if you go to this next page,
are you using this? Like I know that for Redshift, but personally, I use it.
yes, that is why I am at this level, so that I can present you. Google Cloud Storage, Cloud SQL, Cloud Compute Engine, all these services I am using since a lot of time.
Not facing any problem.
No, not at all. It is my duty to explain if any problem is there, so that you guys can aware of that before using this platform, right?
One question is when you showed the comparison of pricing and the performance.
Right.
It was all lopsided towards how the platform is better and stuff like that.
Correct.
Now,
the downside of the Google Cloud, yes. Good question it is. So
either the prices are low because it is some sort of a predatory pricing like Geo, or it is just an interactive thing.
We cannot compare Indian company with the Google. The first thing, Geo. Right. I got your question. So the thing is that the downside of this, like the disadvantage, I must say, using Google Cloud. The first disadvantage of, not disadvantage, like which is lesser than AWS, it has the limited services. Like AWS has more than 150 services, and the complete A to Z services AWS offers. So there are a lot of limitations if we are using GCP. You have seen a lot of, like for Cloud SQL, we have the option of only MySQL and Postgres SQL, right? We are in AWS, we get the this Oracle SQL Server and all these things, MySQL Aurora. So all the MySQL engine we can get in AWS. The important thing is downtime, right? AWS is the more mature model. AWS has started their services way earlier than Google. AWS is 5 years elder than GCP. So that is why AWS knows how to handle their infrastructure. AWS provides lesser downtime. So there are some resources available where I read, like in 2016, the total downtime is around 11 hours of GCP per year downtime, and wherein in AWS it is around 3 to 4 hours. So here is the difference. Although Google has a lot of data centers, there is fast connectivity, but they are still in growing phase, in developing phase. They are developing their services, but they have to manage the downtime, which is the most important and critical things. If we are using our platform in cloud industry, if we are in banking sector, if we are in our live website, our customer will never agree if our website is down for 30 minutes or 20 minutes. So the important thing is that. But I am sure Google will overcome it. Google will come up with a lot of good strategy so that their downtime can be reduced. So those number of 2016 and like still 2017 data is.
I think they have more data centers. AWS.
Right. So connectivity, AWS, lot of data centers, and to have the proper backup model of their data, right?
So you are migrating your Indian customers or
no,
foreign customers?
No, for customers.
Okay. So there is no data center in India.
No, not like that, because Google, it is based on our customers. Some of our customer, although they are the overseas customer, but they have the payment thing. Like for example, one of our customer, they have the restrictions is there that no data should be stored inside the particular country. If it is an Indian customer data, then we cannot store outside India. Right. So for that customer, earlier AWS did not have their data center in Mumbai. So we used to have to store their data. So we used to use the NetMagic data centers. It is again a cloud provider, Indian cloud provider, typical Indian cloud provider, NetMagic. So it is Mumbai-based company. So we used to store their data in those data centers, right? But then around 2 years ago, that AWS launched their data center in Mumbai region, so we immediately migrated their data from NetMagic to AWS. So it is not the thing that it is based on any reason. It is based on a requirement, the regional storage of data.
Requirement is for faster access?
Not for faster access, for lesser latency. For lesser latency, and these kind of requirement, like for example in China, the government is no data should come. There is a specific firewall rule need to be set to in and out data through that China region, right? So currently we are developing infrastructure for our one of this client in which the data goes in and out in the China region. So it is very crucial object for us, because we need to store local data in China data center, and with the help of proxy we need to migrate the data to our data center. All these things. So coming back to our client, this is product and services where we are seeing like these compute management tools, App Engine, Big Data, these many services provided by GCP, right? In management tool, the stack driver, monitoring, logging, error reporting, and right. So lot of services. I have covered most important services like storage and in this big data. These are the services.
So they also have classes like Glacier and Exploit Access. Like that in cloud storage?
I have explained, I have told you the nearline storage, full line storage, right? So okay, so I have logged in cloud.google.com and I will go to console. So this is a dashboard where we can see all these things. The project, as I told, there should be one project under which we can create resources. So this is my project. ID and project number are unique. So this is the dashboard. We can see I have a few instances running. We can see the summary here, the SQL database summary, the API call we can see, right? Resources, compute engine 5, cloud storage 4 buckets, cloud functions, cloud SQL. Okay, so we will see this compute engine, and here you can see all the services: cloud launcher, billing, support. I am under compute. I have told you app engine, compute engine, Kubernetes, and cloud functions. Under storage, we have seen this big table, storage, SQL, spanner. Right? This is the networking, VPC, network services. Stack driver. It is like AWS CloudWatch. It provides the complete monitoring and logging under this stack driver. Container registry. These are the services of BigQuery. Big data. Right. So we will see the compute engine. These many options are there. So right. So this is the VM instance panel. Instance group. First of all, okay, I will show you how to launch an instance. So we need to click on create instance. Right. Instance, it is a virtual machines we are going to create it. Right. Instance 5 zone. The physical location where we want, in which region, US region, European region, right, Asia region, Australia, and all these things. So we will launch any of the in USC. And this is a machine type. The wonderful thing, these are the predefined machine type. As I shown you in my slides, so standard machine type, high memory machine type, and high CPU machine type. So we can choose anything, but this is the good feature. We can choose as per our requirement. For example, I want 1 CPU and I want 2 GB RAM. Although it is not mentioned in this basic view, right? So as per my requirement, so I can select any number of core, 8 core and this 7.2 GB. So it is limitation. In free trial we can select only 8 core, but right here you can see upgrader. But I am giving this demo from my free account, right? So we can create up to 96 core if we upgrade our account. Right, so we will select one CPU and
there is some ratio between CPU and
right, balancing ratio should be there. CPU, yes. Another thing, important thing, we can choose the CPU platform, Intel processor, which processor we want, we can select. AWS does not provide this feature. Okay. And another thing, GPU, we can attach number of graphical processing unit, and also we can select this GPU type. So these are the features which makes Google Compute, we can confidently say it as a product of Google, right? As per our choice, as per requirement, we can build our environment, right? So this is the disk option. These are the public images, right? So public images, I will select this CentOS, application images, custom images, snapshots, existing disk, right? So these are the options we can select. So I will select this CentOS 7. Boot disk type, currently it will launch with 10 GB boot standard persistent disk. So I have explained this, what is the standard persistent disk and SSD disk. So I will select this SSD persistent disk and 10 GB, right? And identity and API access. So we can define how many services can access this instance within our project. Okay?
Does it support Windows also, not yet?
Yes, it supports. And this is the access of API, so that all these services can access. By default, I will allow default access, and this is the firewall. I will allow HTTP traffic, right? And in under management, I can give the description, demo instance. I can give the tags, name, right? And this, I can attach additional disk with this instance. And here you will see this read-only and read-write features, right? If we select this read-only feature, we can attach this disk to multiple instances. Another feature which AWS does not provide. Okay, so as of now, I will not select. I can have the encryption, the networking tags. These are based on the tags like in security groups. So we can have a set of network tags. So for example, I can define this HTTP traffic, and I can attach this network tag to multiple instances. And based on this tag, I can allow or deny traffic to multiple instances. And this is SSH keys option. Again, good features. Here in AWS, we have limitation, like we must have to download the key pairs which AWS provides at the time of launching the instances. Here we can give our customized key pair. Don't need to store the key pair. We don't need to worry about like all this managing and storing keys. At any time, we can create our own key pair. We can upload our own key pair on this. So, right?
You can change the key pair later also.
Right. So, for example, I will generate a key pair. Right, so I will give it copy it. Okay, so I have given my key pair here. Right, so
what are these labels inside manager?
Text, right? So environment I can give. This is the production or staging environment. These are the attributes. We can sort out our instances based on these labels. Okay. Environment is I can give is a test environment, right? If we have n number of instances, for example, we have 1,000 instances, and I want to select how many instances are in production, how many are in test, how many are for the staging environment. So we can sort those instances based on these labels. Okay. And another option is a startup script. I can give this startup script with like if I want to have anything, for example, Apache I want to install. Once our instance get boots up, so I can give any scripts in this, right? And so this again, this is the availability policy. If we want preemptibility, we can define it. automatic restart on these things. So there are a lot of options, but what we have done till now, we have given the name of instance, we have selected zones, number of cores, memory, right? So, and I have selected the OS. That's it. Now just observe the boot time. Once I click, it will get ready in 10 to 15 seconds. This. And that's it, right? So the amazing features. It generally takes around 3 minutes, 3 to 5 minutes in AWS, right? So it is starting. The another good feature, we can connect this machine from this window itself, right? Open in browser window. So it automatically stores key and those, and that's it, right? Our instance is ready. So this is the power of GCP, Google Compute Cloud Platform, and Compute Engine. So now we have this. Yes, we will try to get its access with the keys which we have. Okay. So the public IP of this instance. This is the key which we just created. That's it, right? So okay. Okay. So the two ways we can launch with PuTTY with our custom keys. Okay, we can launch with this cloud, this terminal in the browser-based terminal, and the third thing is we can launch this Google Cloud Shell. In backend, Google launched a Cloud Shell for us, so we can connect to any instance with this. Right. AWS is also provided, but we need to give the path of our keys if we want to connect our instance with the help of browser, right? So, like this. So, you have seen, right, how fast, how quick we can deploy our instance on Google Cloud Platform. So these are the instance group. I can create a collection of instances. Based on that, I can start the auto scaling policies, right? If we want to have on a particular group of instances, for example, web server. So we can create a group web server, and we want to apply any patch on those groups, so we can immediately do that. The instance template is, right, it is like predefined template we can define, and based on this template we can use this template in auto scaling, right? Disk. So we can manually create disk. These are the disks which are attached to this instance, and we can anytime we can create additional disk and we can attach, right? Disk name and all these things we can put here. Size, disk type we can select, persistent, standard disk, and anytime we can attach up to 128 disk to any instance. We can take a snapshot of any disk. What is a snapshot? It is a backup of a disk. With the help of a snapshot, we can launch similar disk. Images of instances. These are the images. So at any time we can take images and we can launch instance with the help of that image. The TPU, I have told you, tensor processing unit. This is the most fast. You can see the latest generation of the machine learning hardware that powers Google Search, Street View, Google Photos, and Google Translate. Right? So Google itself uses these TPUs. Commented use discounts, and this is kind of reserve instances, right? So we can use, another important feature here in what we have in AWS, we choose the instance type. For example, we want to do an instance reservation for i3.xlarge instances, right? Or m1.xlarge instances. We want to pick the option for reservation, but here in Google Cloud, we have the facility, we can simply reserve the number of CPU and the RAM, right? If we want to use the 1000 CPU and the 64 TB of RAM, I can simply reserve it for 1 year, and I can create my custom machines based on these parameters, right? So it is a good thing. Based on the requirement, I can use my reservation, right? And what in AWS, if I have reservation for particular kind of instances, for example, i3 series or C3 series, and in future my requirement gets changed and I want to use another series, then the problem gets created in AWS, right? So these are the things.
Which load balancers are supported?
Network load balancers are supported, HTTP and HTTPS. Right.
Classic load balancer.
Correct. This is the terms of AWS, right? So here in
would they also have application load balancer?
Network load balancer they have. It is the combination of all these three application, and because we know a network are the latest network load balancers are the latest in AWS. So Google already provided those load balancers. Combinations of we can select these things, right? So we can also import our VM, right? So these are the things under compute engine. Fine. So in this way, we can quickly launch and quickly set up our instance in Google. So, okay, so this is what about Google Cloud Platform and the services offered by Google. I hope it is clear to all of you. And any questions? Questions are welcome. If you have any of the question, you can discuss. Yes, sure. Yes, you can. Application, I think it has. Of certifications are there, and one is for developers, one is for solution architect, and another is for 4 is there, right? Professional cloud architect, professional data engineer, G Suite Administrator and G Suite. Right? So these are the good thing if you want to know all the services. So first stage is to go with the professional cloud architect. It is like AWS certified solution architect. So it covers all the services and their major benefits of Google. Data engineer is the deeper inside of the services like big data, right? And the basic course is basic certification is a cloud architect, and data engineer is the next level of cloud architect. You can see demonstrate your proficiency, design and build data processing systems and create machine learning models on Google platform, right? So big data, machine learning, artificial intelligence, and here you will demonstrate your proficiency to design, build and manage solution on Google Cloud platform. So you should know the
domain specific.
Right. You should know all the basics of the major services of Google. So you will go for this professional cloud architect. And this is the deep dive into the specific services like big data, machine learning, and artificial intelligence, all these services. Right. Any other questions?
How support for Python-based tools like Django, Flask, GCP?
So we cannot say it supports. For example, you can deploy your application anytime on Compute Engine. Google Cloud Function is there. Yes, we can easily install. It supports all the languages. It depends on our operating system, right?
No, I think in AWS server you can do anything on server.
Right.
But in let's say Lambda case,
right?
They need to provide you runtime.
Correct. So they
especially for this Django and Flask kind of vulnerabilities in Google.
Google currently provide this Python, Ruby, and this Go. 3-4 major platform Google provides for cloud functions. Cloud function, not for this.
Server is
Right.
free. Whatever.
We can do anything on the server side. Right. Any other questions? Yes.
Last week I deployed a Go language project.
Okay.
And I'm using the GCP, but I'm not much aware about app engine versus the computing engine, internal how it works. So I'm a little bit confused about which is better, computing engine or app.
Okay. So first of all, they are not linked internally. They are complete different thing. Compute engine is infrastructure as a service, and app engine is platform as a service. Right? In compute engine, for you've just seen, we need to give the virtual machines, CPU, virtual CPU, memory, and all these things. Whereas in app engine, you just need to define the operating system. That's it. And define the environment, in which environment you want to deploy your application. For example, Python, Ruby, Go, anything. And you don't need to worry about the infrastructure underlying hardware or the operating system, right? It is completely managed by AWS.
For Go,
it is not, don't get confused, it is not related language specific. For the, it is the choice you should select. If you want platform as a service of infrastructure service, if you want, it should be managed by Google, so you should go for App Engine. If you want to manage yourself, you should go for the infrastructure service Compute Engine, right?
Yeah. What do you mean by managed by Google? It's like
management. Okay.
So let's say I have created a server and it is managed by Google. What do you mean?
No, it is not. Managed services means RDS. Cloud SQL, where you do not get the access of hardware. Although you know
it's only abstracted. You just store your data. And your data.
Right. Managed services, we cannot say Compute Engine is a managed services because we do manage. We are responsible for operating system, right? We are responsible for its security, the scaling, down scaling, up scaling. But in this managed services, for example, Lambda, we are not responsible for the resources in backend that is using, like how many number of servers it using, what environment it is using. So it will be managed by Google, and we don't have to worry about the load, the memory, the disk space, all these things we don't have to worry about. Google will manage it. Not only Google, any of the cloud provider will manage it.
So App Engine is actually mapping to Lambda.
Managed service.
It's a corresponding.
Not. It is not a mapping to Lambda. App Engine is a mapping of Elastic Beanstalk, right? Mapping of Lambda is Google Cloud Functions.
Because GoDaddy is the virtual private network is our computer engine and here the thing is like our app engine. GoDaddy and this is here.
I did not get your point.
GoDaddy provides virtual private network.
Right? Not virtual private network, it provides the virtual hosting.
Oh, sorry, okay.
Right.
So dedicated server is like computing. We manage all that server's configuration and all that.
Right.
They manage it.
Correct. You can say if we want to host our website ourselves, then we launch, for example, we just launch a server, we will install a Apache on that server, we will put our HTML file, we will manage everything. And if it is provided like platform as a service, GoDaddy has provided a platform for us, so in which we can simply put our code on their platform and our website gets ready. Any other questions?
It's more on the domain. So consider the use case for banking and financial services.
Okay.
So platform as a service, why a banking client will come to Google and say, hey, I'll give you my data and you provide me the services? That will never happen, right? Because they are reluctant to keep the data outside their organization. So does Google provide any hybrid model of the cloud? They come to a bank and they say, we will deploy the infrastructure in your bank itself. Does that happen?
So then, where will come the cloud, right?
It's more on space, right? Services they do use.
That services are called the data transfer services, where you store your data on premises and your data gets transferred to the data centers. First of all, the banking sectors do not use the cloud services, for example, for the sake of security, but most of the banking sector has started using cloud platform because they have a lot of security compliance, right? So because the banking data should not go outside our country, so Google or AWS has data center in the Mumbai region, so we can store their data in Mumbai. And if anyone want to privately store their data, for example, their data should be stored in their data center only, but one backup may be stored on their cloud. So we can store our data in our data center and we can export the data. We can transfer the data to their data center, explicit data, not all the data. For example, password and other things we can store in our data center, and all these are basic information we can we can transfer on cloud-based data center. Yes.
Mapping for cloud front.
Yes, Google Cloud Distribution, CDN, Google CDN. Provide the same thing. Any other questions? Okay. Thank you, everyone. Thank you for your time. Snacks is ready in the canteen, so you can have it. Thank you so much. Correct.